In question 10, the diagram shows a cross-section RASB of the body of an aircraft. The cross-section consists of a sector OARB of a circle of radius 2.5 meters with center O, a sector PASB of another circle of radius 2.24, and a quadrilateral OABP. Angle AOB is 2 upon 3 pi and angle APB is 5.6 pi. In part A, we have to find the perimeter of the cross-section RASB, giving our answer correct to 2 decimal place. Now, this cross-section, the perimeter of the cross-section will consist of 2 sectors. One of them is ARB and the other is ASD. So for the perimeter, we will write it as perimeter will be equals to the arc length of ARB plus the arc length of ASB. Now to find the arc length of ARB, first we need this angle. Now as we know that the total angle is 2 pi, so the angle AOB for the sector will become 2 pi minus 2 upon 3 pi. So we know that the arc length formula is S equals to R theta. The radius will be 2.5. So the arc length will be 2.5 multiplied by by theta, which will be 2 pi minus 2 upon 3 pi. So 2 pi minus 3 upon 2 upon 3 pi will be equals to 2.5 multiplied by, so that will become 4 upon 3 pi. Substituting this in the calculator, the answer will be 10.472 meters. So this is the arc length for ARB. Now finding the arc length for ASB, so arc length of ASB will be equals to R. So in this case, R is 2.24. And the angle is given as 5 upon 6 pi. So 2.24 multiplied by 5 upon 6 pi. Substituting this in the calculator, this will give the answer. So this will be equals to 5.864 meters. So this will be 5.864 meters. So the total perimeter will be equals to 10.472 plus 5.864. Adding these two, the final answer will be 16.34 meters. As we have to give our answer to 2 decimal place, so we will leave our answer to 16.34 meters. In part B, it is asking us to find the difference in area of the two triangles AOB and APB. And we have to give our answer correct to 2 decimal place. Now finding in the first step, finding the area of the triangle AOB. So AOB, we can apply a sine rule to find the length of AOB. Now to find, we know that this length will also be 2.5. So for the area of a triangle, the formula is half AB sine C. Now as both of the lengths are 2.5 as it is a radius, so we write it as 1 upon 2 into 2.5 into 2.5 into sine of the angle is 2 upon 2 pi upon 3. Substituting this in the calculator, the answer will be 2.706 meters squared. So this is the area of the triangle AOB. For the area of triangle APB, this will be equals to now. So in this case, this length is 2.24. So this length will also be 2.24. And the angle is 5 upon 6 pi. So this will become 1 upon 2 into 2.24 multiplied by 2.24 multiplied by sine of 5 pi upon 6. Substituting this in the calculator, the answer will be equals to 1.254 meters squared. Finding the difference, so the difference will be, we will substitute the values, both of the values in the calculator and subtract them. So the final answer will be 2.706 minus 1.254. The final answer correct to 2 decimal place will be 1.45 meters squared. In part C, we have to find the area of the cross section RASB, giving our answer correct to 1 decimal place. Now to find the area of the cross section, so we can see that we have one sector over here, another sector over here, and this part, basically the quadrilateral part, is the difference of the two triangles that we found in the previous part. So first we'll find the area of the sector OARB. So in the first step, we can first find the area of sector OARB. And as the formula is 1 upon 2 into r squared into theta. So this will become 1 upon 2 into 2.5 into 2.5. And the angle theta we found in the first part was 4 pi upon 3. Substituting this in the calculator, the answer will be 13.09 meters squared. Now in the next step, we'll find the area of the smaller sector. So the sector is OA, so that will be PASB. So finding the area of sector PASB, this will be equals to 1 upon 2 into, so the radius in this case is 2.24 into 2.24 into the angle, which is 5 upon 6, 5 pi upon 6. Substituting this in the calculator, the answer will be 6.57 meters squared. Now we'll also add to the area of these two sectors, we'll add the difference of the two triangles, which was 1.45. So the total area will be equals to 13.09 plus 6.57 plus 1.45 meters squared. Substituting these values in the calculator, the final answer will be 21.1 meters squared, as we have to give our answer correct to one decimal place.